All right, so intervals of increase and decrease, it basically is exactly what it sounds like. It is when you look at a function on a graph and you determine where is the graph going up from left to right, that would be an interval of increase. Where is the graph going down from left to right, that'd be an interval of decrease. There is also the option that a graph might just be flat or horizontal from left to right. If and when that happens, we don't call that an increase or a decrease. We call that an interval where it is being constant. We won't really see those with polynomial functions. Polynomial functions are always either increasing or decreasing. One thing that makes intervals of increase and decrease a little bit tricky to determine and to actually write is that you're always supposed to do this, give it in terms of the x values. Like, yes, you're looking at where the graph is going up or where it's going down, but you're going to read the values for that from left to right on the x-axis. So here's an example. One of the first things that I suggest is that if you have a graph, just go ahead and draw vertical lines that split the graph into the different sections, like anywhere where you see that it's changing what it's doing. Whether it's changing from increasing to decreasing or whatever, you just split it up, because then this is going to create, in this case, 1, 2, 3, 4 different intervals. And then after I've split the graph, then I'm just going to label it up at the top. Again, from left to right, this would be increase. Now in this little bitty interval, I'd say that's going down from left to right, that's a decrease. From this section, I'd say it's going increasing, and then this section is where it's decreasing again. So I just go ahead and label it like that. Then your intervals, again, you always read it from left to right, which you have to consider that all the way to the far left, that's like negative infinity, and then all the way to the far right, that's positive infinity. And then another reason why these vertical lines are helpful is because they literally identify, like, that is where this first interval is going to end. Like, I can literally see this was an increasing interval, and I can see that it went from negative infinity until this point right here, because you're supposed to read it in terms of the x values. So I'd say from negative infinity to -1. Now we use parentheses on that, not a square bracket, because at -1, it's not increasing or decreasing. So we don't want to include it. We use parentheses. Now again, that's an interval of increase, but you'll notice in this example, we have another interval of increase. And so we would use, sometimes you see a symbol that looks like this. It means union. It's just a way of saying it's this interval and it's also another interval. I don't really care if you use that symbol though. If you just list out all the intervals where it's increasing, that's good enough. And so again, this is our second interval of increase. I look right here and I'd say, okay, this is where it starts, this is where it stops. This is 0, and then this is 1. So I'd say from 0 until 1. It's a really small interval, but in that interval, it is increasing. And again, we use parentheses because at those specific values, it's not doing anything. And then I do the same thing for intervals of decrease. I'd say, well, here's my first one, and I read it from left to right. And so I'd say this one starts at -1, and then it stops at 0. So I'd say from -1 to 0. Sorry, my pen froze there for a second. From -1 to 0, that's the first interval. Combine that with, or the union of that interval with, this is the other decreasing interval. And so I'd say, well, it starts right here at 1, and then we're going to assume it never stops. And so we'd say from 1 on toward positive infinity, we're assuming that it's always going to be decreasing in that interval. Now, again, I'd talk about constant intervals just so that you know that it is possible. But again, we don't see anywhere it's just like flatlined. You won't see that with a polynomial function. So if you're ever asked about the constant intervals, you would just say there are none.